This question is the IMC 2021 question 16, and it covers areas and circles. The question gives us the side lengths of 2 pi of the square, and we have to get the area of the shape you see on the right. So first of all, we have to add the area of the square and the 4 semicircles that you can see. So the square would be side squared, which would be 2 pi squared, plus the area of the 4 semicircles, and that would be equal to 4 times half pi r squared, as I've written here, which would be half pi radius. We know that the radius is half the diameter, and each of them are equal. So we get pi for each of them, and pi here as well. So it would be pi squared. That would be equal to 4 times half pi cubed, which is 2 pi cubed. Therefore, we get 2 pi squared plus 2 pi cubed, and we get 4 pi squared plus 2 pi cubed, which have the common factor of 2 pi squared, 2 plus pi. And out of the 5, we get E, which is the answer. We can also use an easier method, a quicker method, which is exactly the same with the one we've just done. But we can see these 2 semicircles here adding up to a single circle, and also another semicircle pair, which will add up to a circle. Therefore, we can write, let's use another color, we can write the area of the square, which is the same, plus 2 times pi r squared. And here the r is equal to pi, as I've explained before. Therefore, we get 2 pi cubed, which is the exact same with the previous answer. And we also get E here. Therefore, the answer is E. This question is IMC 2021, question 23, which covers areas, Pythagorean theorem, and circles. The question shows a diagram with a semicircle center O and radius 2, and a semicircular arc with diameter PR. We know that POR is a right angle, and we have to get the area of the shaded region. As you can see, it's very difficult to get the area of the shaded region. Therefore, we have to use the semicircle, once again, with a diameter PR, and exclude the area, which is not shaded. Let's label it area 1 here, 2, and 3, so that we can just exclude 2 after we get the area of the semicircle. To get the area, we have to use the equation of a semicircle, and that will be when we know the radius of the semicircle. Therefore, we have to get the length of PR, which is the diameter. And to get the length, we have to use Pythagorean theorem of triangle POR, which would be PR squared, which is the hypotenuse, would be equal to OP squared plus OR squared, and that is 2 squared plus 2 squared, because it's the radius of the bigger semicircle, and that is equal to 8. Therefore, PR is square root of 8, that is 2 root 2. Therefore, we know that the radius is half of the diameter, and we get root 2 as a radius. Therefore, let's label it R1, the smaller one, and R2, the bigger semicircle. What we need to get is R1 minus the area 2. We know that R1 is half pi, what we got here, which is root 2 squared minus area 2. Let's calculate it. Half pi times 2 minus area 2, which is pi minus area 2. We now have to get the area 2 using this area, which is area 2 plus area 3 minus area 3. That's how we get area 2. And therefore, we have to use the semicircle equation again, but half of it because it's a quarter of a circle, which is quarter times pi r squared. We know r is 2 here, since it's the radius is r2. We get 2 squared minus this is a right angle triangle with sides 2 and 2. We get half base times height. Therefore, we get quarter pi 4 minus 2. And that is equal to pi minus 2. Therefore, we know that area 2 is pi minus 2. And if we go back to here, where we need the shaded area, we would get, therefore, pi minus area 2 is equal to pi minus 2, which is pi minus pi plus 2, because brackets. Therefore, we get 2 as the answer. And out of A to E, we get B.